Okay, for this question, uh, you have to find the gauge pressure of air. So where is the air? The air is here. Okay, and based on our understanding on the pressure of air, pressure at any point here, even though it's at different elevation, because it's air, we can assume it's the same. Okay, so we are looking for P air at point 1. Air, which is the gauge pressure at point 1. From there, where do we go? We go, imagine that we are swimming, okay? Now, you are here now. You have to swim downward, okay? Up to this point. Okay, so because you are going downward, you have to plus because here you go downward. And then, we know that pressure increases, pressure increases when we go below sea level or below your datum point. Okay, so plus how far do you have to travel? You have to travel 0.2 is here, 0.3. This part is not given, we put it as x first. Okay, so 0.5 plus x. And you are swimming in which liquid? You are swimming in water. So the density of your water is 1000. Okay, and then the specific gravity G is 9.81. Okay, so this is the density, this is the G, and H is this one, that is the H. Okay, so now you are here. From there, where do you have to swim? You have to swim upward. Okay, you naik atas. When you go upward, you have to minus. Once you go upward, the pressure decreases when you go higher. Okay, negative. How far do you have to travel upward? You have to travel x plus 0.3. So minus x plus 0.3. And in this case, you are traveling in which liquid? I hope you can see clearly the color here is slightly a darker color, so it's water. So times 1000, and then times with the G 9.8. Again, P equal to rho GH. So this is your H, 9.8 is your G, and then this is your density. Okay, and then you are now at this point. You still have to travel upward or downward. Okay, in this case, okay, because this here from here to here is the same H. Okay, so we can cancel out. Because if you go upward, you minus rho GH 1, and then from here you have to go downward plus rho GH 1 as well. Then I can cancel out. Okay, so I would like to go from this point straight away to here. So from here, where do I swim? I swim downward. Okay, so plus, how far do I have to travel this time? I have to travel H2, 0.3. So 0.3 times, okay, this time I'm swimming in oil. I've changed the liquid. It's no more water, it's now oil. The density for oil is 850. 850 times with 9.81. Okay, now I am here. Okay, and then from here, again, if you want to do it one by one. You can as well from this point. You have to travel downward up to this level. Okay, we name this level as that distance to be y. Okay, so here is also y. So when you travel downward, you travel because you are going downward plus rho g h, which is in this case is y. So plus rho g1. From here, you have to swim upward. So minus rho g. How far do you have to swim upward? Y as well. So y. So you can cancel out. Okay, that's why normally if you are familiar with manometer already, you can simply jump. Okay, from this point to this point. Okay, so now you are here. From there, you have to swim upward. So negative. How far do you have to travel this time? H3. So it's 0.46. 0.46. Now, my color have changed. I'm not swimming in oil anymore. I'm swimming in mercury. So the density of my mercury is 13,609.81. Again, this is H, this is density, that is G. Okay? So I am here now. Have I reached my destination? Yes, because that is my destination, my end point. So once you have reached your destination, always put an equal sign. Okay, here. At that point, what is your pressure? At that point, my pressure is 0 gauge. Again, because I want to maintain my answer in the unit of gauge pressure. Okay, so it's become 0 kilopascal equal to gauge, which is also actually equal to 101 kilopascal atmospheric lah. But this time, because the question specifically asks for gauge pressure, so we simplify. We don't have to include that. Okay, now we solve for this equation. Okay, just now maybe you are wondering how to find the x because x is not given. Okay, now look at this equation here. As you can see, you have positive x here and then negative x here. So actually, automatically this x will be cancelled out because, yeah, can be cancelled out. Okay, so from there we solve for this question. Find your PA. Okay, so from our equation here, you can rearrange. Okay, and you can remove your x already by this time, leaving you this part. Okay, press the calculator and find the answer. Okay, so here you have 56,907.81 Pascal. Okay, we look at the unit key. P is equal to rho g, which density is kilogram per meter cube, and the gravitational acceleration is ms square, and this is h meter. Okay, so you will have kilogram meter square meter cube s square. Can cancel out this. You will have kilogram per meter s square.